In this video, we will discuss inelastic and elastic collision. For an inelastic collision, the two objects stick together and move off with a common velocity. They conserve momentum but do not conserve kinetic energy.
Suppose two cars with mass 1 equal to 1.5 kilograms and mass 2 equal to 2.5 kilograms approach each other with initial velocities of 2 meters per second and 3 meters per second in the opposite direction respectively.
The two cars collide in a total inelastic collision. What is their common final velocity after the collision? In an inelastic collision, initial momentum total is equal to the sum of mass times velocity of each car. To solve for initial momentum total, we can plug in our givens for the following equation. P total equals P1 plus P2.
Great! Now we solve for our initial momentum. Next, we can solve for the final velocity. In an inelastic collision, as stated, momentum is conserved, so P initial is equal to P final. We know the value of P initial is negative 4.5 kilograms times meters per second. Our final total momentum will be equal to the sum of the total masses times the velocity in which we are solving for. Now that we have established a working equation, we can plug in our values and solve for final velocity.
Now let's look at some elastic collisions. In elastic collisions, momentum is conserved and so is kinetic energy.
Car 1 with a mass of 4 kilograms has an initial velocity of 2 meters per second, collides perfectly elastically with car 2 with a mass of 6 kilograms moving at an initial velocity of 4 meters per second in the opposite direction. Let us find the velocities of two cars after the collision.
First, to solve this problem, we must use conservation of a momentum that states momentum final is equal to momentum initial. Knowing that P equals mv, we can derive the equation P1 times V1 final plus M2 times V2 final equals M1 V1 initial plus M2 V2 initial. We plug in what we are given. We are left with two unknowns, V1 final and V2 final.
In order to solve this, we must derive another equation. The conservation of energy says K final is equal to K initial. We know that K is equal to 1/2 mv squared. So we can derive a new equation that fits our givens and solves our problem. We can use the conservation of momentum equation and solve for one of the unknown variables and plug it into our second equation.